the essence of mathematics. I don't claim to know the essence of mathematics. I don't know if you can really teach it, but one thing that certainly comes out of math is one concept can be used to simplify a vast array of complicated problems. So if you just take adjacency matrices, I'm sure some of you have taught like transportation problems, shortest paths, internet pages and links, and social networks. See, the same concept can solve many different things. This is a little video here, and it shows what they're doing. It's just 2-3 minutes long here, and I'll play it for you for something a little bit different. And what it has to do with is how they're using math and that to analyze social networks and what really people are doing. And what's different about this is everything before used to be, it was based on what people say they're doing versus, you know, you ask them, like, okay, here's one. 18% of people say that they earn in the top 1% of income earners. They're in the top 1% of income earners. So what is there? There's a misconception, right? Clearly. Okay. So that's what this, so now it's changing the lay of the land a little bit here. So.
I'm Peter Dodds. I have a background in math, physics, electrical engineering, but I've spent a lot of time also in the social sciences as well. Understanding how large groups function, we've of course been worried about how we should run society forever, really. We've moved to an age where people are connected online. People can communicate at incredible rates with all sorts of people. They can digest and move information around. It's unparalleled. It's crucial that we understand it from a basic science point of view. What happens when you connect people in different types of networks, for example? Will they produce a good outcome, a biased outcome? And some of our work in particular then is looking at emotions, how emotions spread, the contagion of emotion, if you like. There's one site in particular, wefeelfine.org, that we've been harvesting data from. They, of course, in turn have been harvesting data from blogs. Any sentence that starts with I feel or I am feeling, they pull that off a blog, and then you have a timestamp, and in some cases you have the age of the blogger and where they live. So you have this demographic data, which is very important. And we've been able to find out a number of things, because now we're watching what people do. We're not asking them how they feel. We're watching how they express themselves. This is really getting at a fundamental problem for measuring how well society is doing. Right? We're not used to understanding how 100,000 people will behave. There is a transition, I think, in the social sciences where you move away from just having ideas, abstract ideas about how society should function, how an economic system should function. We can go and look. Now we can go and look. We just did not have that data before.
So the idea there is now they're actually going and looking, they can analyze it, they can apply math into what is actually happening there, which I think is very interesting. Okay, so we use mathematics to find out secrets, and we have used things like cryptography for a long time to keep secrets safe. And in that case, in that situation, what you want to do is you just want to keep like bank accounts and that. You don't want any information out of that. But now there's this idea that's coming in here is groups of people now can compute collective data without giving up any of their individual data. So here's a really simple example. It's kind of a nice little secure function evaluation it's called. Suppose we have 3 individuals. They want to know the sum of their weight for some reason, but they don't want to tell their weights. Okay, any individual doesn't want to say their weight, whatever you wanted here. Okay, now kind of this is a very simple example here, but using modular arithmetic. So basically, let's say we got 3 people, 155, 210, 184, they're 549 pounds. They'd like to get the 549, but nobody wants to say their weight or whatever the number might be. All right, well, what we can do here is we can apply modular arithmetic. So Each person privately selects 3 numbers between 0 and 1,000 whose sum equals 1,000 module weight module 1,000. So the 155 person could pick 255, 563, 337, 1155, which mod 1,000 is 155, okay? And so what they can do then is they will all do that. So let's just hear step 1. First person picks 3 numbers. Second person, blue person, picks 3 numbers. Third person picks 3 numbers. Okay, so that's the first step. They do that in private. All right, next step then, step 2, what they'll do is they'll distribute 2 of their numbers to each other. So if you look at this, let's just take the red person. The 255 gave that to the blue, 563 gave it to the green, but kept the 337 so then nobody knows, can't add all the red. Nobody has all the red information. So you see, then they each get 1 color. Okay, now they what? Add them all up. We can. So for step 3 here, they can add them all up and simplify them here. So they add the 3 numbers, you get 1034. So 34 mod 1,000. 349, 166. Now you can see what's happening. I'm sure you're way ahead of this probably. But if you add those numbers then, what is happening here then is we add the 3 numbers and you get the 549. So there's a lot of this idea that they can do collectively, they can figure out data.